Hi, good afternoon. It's very good to be here again to talk to you about IoT. And today I'm going to talk about security and authentication in the area of IoT with specific emphasis on the Industrial IoT. So if we look at what's been happening the last few years with IoT, the connection of things to the cloud, things to things, machine to machine communications and data transfer, we can see that huge transformations are being driven by this technology. Reports talk about between 20 and 50 billion nodes connected to the internet and to the cloud by 2020, depending on the report that you read. But some of the changes that are going to be wrought by this connectivity transformation are going to be things like predictive maintenance and remote management. Those transformations are already underway. That technology is being deployed in industry already. The sharing of data across ecosystems and industries, big data analytics, creating outcome-oriented product service hybrids, real-time machine-to-machine communications for optimized operations, and finally wearables that connect people to machines and to processes for improved people safety and for operational performance. So connecting all these things to the World Wide Web and connect them to each other is driving massive transformations in the way we deal with machines, the way we run processes, and ultimately in the way that we do business. So the Internet of Things is driving a new way of people working and interacting with each other and interacting with machines and processes. If you look at NXP's place in this transformation, then of course we're a key technology solutions provider, and I'll start off in the top left-hand side with the NFC tag and NFC ICs, which are based on RFID technology. It was something that NXP invented a few years ago. By the way, please vote for us on the European Inventors Forum. You can go on there, and there's the two inventors of the NFC technology from NXP, and you can vote for them. We would really appreciate your support on that. So typically the applications for the NFC tags and for ICs are things like logistics, where you might want to tag a pallet or tag a piece of equipment, and of course machine configuration, where you can store the data on a handheld device and you can transfer that data quickly and easily to a piece of equipment to set it up or to authorize it to connect to a network. Sensor ICs, here we talk about pressure, temperature, volatile organic compounds, acceleration. One of the speakers this morning in the main session was talking about mobile phones. Mobile phones in the next few years will have up to 20 sensors on them. So NXP is, of course, a player in that segment as well. And that's primarily around collecting data. And if you think about industrial applications, then, of course, you're going to make use of sensor data, lots of sensor data. Zigbee ICs, we're one of the biggest suppliers to the market of Zigbee, of wireless MCUs that run the Zigbee stack or the 6-LoWPAN stack. We develop the stacks in-house, we author them ourselves, and we maintain them. We're a member of the Zigbee board, one of the first semiconductors to be on the board, and a major player in that market in terms of setting standards and driving standardization across the industry. And then on the ARM MCU side, of course, we're a key supplier to the market of ARM-based MCUs. And in fact, NXP, Philips at the time, created the general purpose ARM MCU segment. That's something that came out of NXP. Before that were primarily 8-bit MIPS-based solutions, and ARM changed that completely changed the MCU landscape. And then finally, the thing that I'm going to talk a bit more about today is NXP's A-Series IC, which is security IC, which is a device which provides encryption and authentication. You can deploy this chip onto end nodes, onto systems to encrypt data and make sure that only authorized people or machines can connect with those devices that have that technology deployed in them. So at the World Economic Forum last year, a survey was conducted with industry leaders, and the question that was asked is, what are the greatest barriers inhibiting business from adopting the industrial internet? And there were a whole lot of questions that were asked there. I want to draw your attention to the second item there. 64% of the respondents said security concerns were the biggest barrier to adopting the industrial internet. If you go down a bit further, there's a second question down there called privacy concerns, and for me they are different aspects of the same thing, different sides of the same coin. If you combine those two things together, security concerns and privacy concerns, you can see that that's probably the biggest concern that companies, IT managers, systems designers have. It's about security. We heard the previous speaker talk about that in great depth. I want to talk today about IoT, about endpoint nodes. How do we connect those securely to the internet? Because I'm going to show you a slide shortly. If you think that endpoint nodes are not secure or not discoverable, you have to think again, because they are. And this poses some huge dilemmas for industry moving forward. So, in a report that was authored this year, the World Economic Forum had this to say: organizations will need new security frameworks that span the entire cyber-physical stack, from device-level authentication, application security, all the way through to system-wide assurance, resiliency, and incident response models. What that means is when you think about internet security and IoT security specifically, you can't simply think about securing a device. You've got to think about the whole information chain. From that end device, through the transport layer, up into the cloud, you've got to secure that data in the cloud. That data in the cloud will probably be worked on and then output to some other nodes or some other geography. It has to be secure all the way through that process. And that's the challenge that we have with IoT and specifically the industrial Internet of Things. You've got to secure the whole information channel. So the other thing to think about is the cost of an attack, of a cyber attack, and I'm again specifically focusing on the industrial aspect here. But if you think about the cost of non-availability, if a factory or plant goes down, the cost can be huge. So you're not able to produce. If you come from a semiconductor industry the way I do, you know that if you have a stop in a fab, very often all of the WIP in the fab has to get thrown out, yeah, because you can't stop a process in the middle without incurring problems. So the cost can be very, very severe. There's a safety issue as well. If a system is compromised, recipes are changed, system parameters are changed, that can lead to some very serious safety outcomes. Equipment damages. Many of you are familiar with Stuxnet, which was a virus that was used by the US to attack the centrifuges in the uranium enrichment program, and they were able to overspin those centrifuges and damage them. Brand and reputation, market share, could also lead on, of course, from there to impacting stock prices and things like that. Recovery costs. If you have a serious issue, you've got to think about what the costs are to recover that situation. Leakage of sensitive information. So process recipes, for example, machine setups. In many industries, how you make things and how you do things are the basis of differentiation and competition. If that leaks out and competitors get hold of that, you lose your competitive edge. Very, very important aspect. And finally, but not least of all, of course, there's the environmental consequences of a catastrophe that could be caused by breaching the system and attacking it. So I mentioned earlier on that IoT devices are easily discoverable. There's a tool on the web, and if you look at the bottom of this slide there, you can actually go onto that website, www.shodanhq.com. And what this tool does, it crawls the net and it discovers IoT devices that are connected to the net that you can breach, that you can get into. And what it does is it maps out all of those IP addresses across the internet, and it builds a database of devices. So if it discovers a device that has a vulnerability in it and it can breach that device, it then builds up a picture of those devices and where they're located on the web. So it knows that that particular type of device, it could be an industrial PLC, for example, can be attacked in a certain way and can be breached. And of course, anyone can use this tool. You go on there. I had a look. You just put your password in. You put your details in there, and you can use the tool. So of course, this means anybody can use the tool, and the tool can be used by people that should not be using it for cyber attacks. So the key learnings here are your devices are discoverable. It's much easier than you think. And the second thing, of course, is that if you want to protect against this kind of thing, you have to think about strong device authentication. Yeah? And make sure that only those machines or people that have the authority to access your device can do so. So a very, very important point. So let's look at authentication and device identity. These are the foundations of trust in IoT and the industrial IoT. And there's 6 things as a minimum that have to be met in order to have trusted interaction between machines or between machines and people. So the first thing is that the access control is role-based. So only if you're authorized can you access that device. And the amount of access you get, of course, is linked to your authorization level. Trusted equipment, so you have to have proof of origin. So the devices that are connected to that network or that system, you have to know where they come from and they have to be certified. Trusted software running on equipment will drive system integrity. You have to know that that is the right software running on that platform. Trusted commands. Trusted commands means only those commands that that machine is authorized to run will run on that machine. If other commands come into that system that are not authorized, you have to stop them because that's the potential opportunity for an attack. Trusted operations, how the machine is used. It is only used in a certain way and within a certain environment and within a certain process. It cannot be used in any other way. If it can be redeployed, it's an opportunity for a cyber attack. And then finally, trusted access to the cloud and servers. And I think the previous speaker spent a lot of time talking about that, explaining the intricacies of that to us. So if you look at the 2 things I've been talking about, one is operational technology and the other, of course, is IT technology. These 2 things under the industrial Internet of Things are converging. And in actual fact, their modus operandi is very, very different between the 2 of them. If you talk about operational technology, here I'm talking about industrial processes where you do things or make things. Availability of computing power and response time is absolutely key for that. It's got to be done when it has to be done. It's very command-centric. You have a central processor that is dictating how things are done, when they're done, and exactly what is done. You have devices which are not easily patchable, and that means you can't easily upgrade the software. If you have a process running in a factory, PLCs, and it's running smoothly and it's producing and the yields are very high, it is risky and can be difficult to go and then make a software patch. The general way of treating these things is to say it's running well, leave it. If it ain't broke, don't fix it. And finally, lots of proprietary protocols. If I think about industrial, I can think about things like Profibus, Fieldbus, Ethernet, and then of course you've got the wireless protocols as well, like Zigbee and 6LoWPAN, which are starting to find their way into some industrial and building automation applications. And of course, this generally is distributed, so you have distributed computing in systems like this. Information technology, on the other hand, it's open platforms. You think about Linux, you think about Windows. The exchange of information generally is with humans. It's data-centric. It's about moving data between machines and people. It's regularly patched. You think about the updates to your phone, think about the updates to your computer, and finally it's centralized. Think about your office network. You have servers, and you connect the servers through your terminals, be that a computer or a phone, but it's really a centralized system. And those 2 things are the 2 things that we have to deal with when we think about IoT. We have to deal with operational technology, which is very specific, and you've got to deal with and closed, if I can use that term, and information technology, which is really about being open and exchanging information. So let's quickly look at some key learnings, and the case we'll look at here is the Heartbleed case. So Bruce Schneider classed it as a catastrophic event, and he rated it 11 on a scale of 1 to 10. And the problem was a bug in OpenSSL, the cryptographic software library for SSL. And the issue here is that it gave access of confidential information to people that were able to breach the system. And things like private keys, passwords, emails, private messages, all of those things became accessible to people that attacked the system. It leaves no trace if you go and attack the system and get through, and it's undetected by intrusion detectors. And of course, because it's on the web, up in the cloud, you can do it remotely. So a very, very serious issue. And the fix, of course, is to upgrade the software, change all the keys, change the passwords and things like that. But for those changes to ripple through, probably about 2 years. So some systems are still vulnerable at the moment. So the key learnings here, of course, for us are security is to a great extent a matter of implementation. Clearly secure and isolate your keys. I think the previous speaker spoke about that. You have to have those separate and not embedded in the data streams in the exchange between machines. And finally, using proven software solutions, of which SSL was, does not guarantee that you have security. You've got to think beyond that. And some of the tools and techniques you can use here, FMEA analysis, AD analysis, to try and uncover potential areas where you could get a breach. And you've got to think about security as a separate issue when you do system design. You can't just assume that the platforms and tools that you're using provide that. So password-based identification, which is generally used for most computers now, it's still used. I use it on my phone. I'm using it every day. We all do that. Is very, very weak. The fundamental issue is that you've got brute force computing power now that enable you to crack those passwords relatively easily. There's a limit to how many passwords and the complexity of the passwords that you can remember. I probably have about 15 or 20 passwords that I have to remember, email, log on to websites, phone, computer, that kind of thing. A lot of people use the same password because it's easy to remember. That's dangerous. They simply crack one of your pieces of software or one of your pieces of equipment, and they've got access to everything else that you are involved with. It's very vulnerable in transit, so when you pass those passwords over the network, they can be intercepted. One-time password technology is not very secure either, and of course, don't use passwords as unique authentication factors anymore, because they will be cracked, and then you have a problem. So, what do you need for a unique and strong device ID? You need authentication. That's absolutely key. You need strong device identity, which authentication provides. You need the use of cryptographic techniques to prove identity. And of course, you need to have a device which is tamper resistant, not only from the software point of view or from the cyber point of view, but actually physically as well. So if you look at the chips I'm going to talk to you about now from NXP, the actual device construction makes it very, very difficult to get into that chip and have a look at how it's made and how the various layers are routed. So it's very important that. So the NXP A-Series Security IC is, we call that the trusted anchor protecting credentials in devices, and it provides best-in-class tamper resistance, and that's been evaluated by third parties, proven and evaluated by third parties. And when we talk about tamper resistance, again, just to stress the point, it's about being software tamper resistant and, of course, being physically very tamper resistant in the construction of the chip. We provide turnkey solutions, so all the back-end server and secure server requirements, we work with third parties to be able to provide that so that you can exchange keys securely and have a secure system. And then finally, of course, on the key injection at the point of manufacture or at the point of service delivery, the solution facilitates that very well. And this device typically will work with your application IC, your microcontroller, or your SoC. So it's an add-on chip that you put on, and it communicates with that device and provides that security. So if you look at some of the use cases for this technology, you've got authentication to other devices in the cloud. So this is protection of infrastructure and cloud services. You've got verification of the device, so you know if a device connects to your system that's been verified, it has the right keys. Protection of software IP, secure pairing of devices. Example given here is a PLC I/O module, where you want to make sure that I/O module belongs with that particular device. Wireless sensors, a lot going on now in Zigbee and 6LoWPAN. Some of you may have seen recently IP camera video streams on the internet. using this technology that's absolutely secure. You cannot do that. You can stream video over the internet and it's secure, and people can't decode that. Role-based access control to devices, setup of encrypted communications. Very important that you encrypt the data when you send it. Signing and traceability of commands, and that is all around accountability and an audit trail. So what we mean by that is that the devices that have this solution embedded in them will only execute certain commands. If you try to attack that device and get it to execute some other kind of command, it will prevent that. Secure activation of device features. This is profile of service, so you may want to only provide certain features or functions for your solution or your service or your product to the user. This device helps set that up. And then, of course, late-stage device personalization, which is linked to the previous point I made. And just to share with you, if you look at the technology we're talking about here, NXP shipped over 1 billion bank cards in China so far. It's the same technology that we're using in those bank cards. So if you think about the millions of transactions that take place just in China every day without incident, this is the technology that is being used for that. So it's very proven, very secure, and extremely reliable. And we're bringing that technology to the Internet of Things. So some of the key applications that we're involved in, energy management and smart grid, covering smart home appliances, gateways, metering, home and building automation systems, industrial PLCs, remote terminal units, industrial equipment parts, remote monitoring system, medical and healthcare, where there's particular sensitivity around data security. We're involved in that as well in terms of home care monitoring gateways, medical devices, traceability solutions, and of course this is to deal with drug delivery and the authentication of medication. Transport, I think was mentioned this morning, we're very involved in that, so this NFC technology that we use as well is on the cards that you have to get access to COMPUTEX, vending, POS terminals, ATMs, IP cameras I mentioned already, and of course security systems. So this is a snapshot of some of the applications where this technology, the NXP A-Series Security IC, is being applied today. So I think just to stress this point, and I think the previous speaker also mentioned this, when you think about security, you've got to think about securing the whole communications chain. It's the integrity of the infrastructure that's important. It's secure access to services and protection of business models, and secure device management, and the ability to transfer important data across unsecured networks. And that's a very, very important point, because you're simply going to be transferring keys and data like that across the internet. And that has to be done so that it cannot be cracked or breached by a cyber attack. So NXP is a big contributor to the IEC 62443 standard, which basically is focused on personnel, training, how you train personnel. It's very important that the people in your organization know how to work with this technology and also are aware of the security problems that may arise. Network design, data protection, event management, and event management in terms of security breaches. Account management, how you configure the system and authorize devices. Software patch management, very, very important when you get to industrial Internet of Things. Backing up data and devices. Authentication is the foundation that the standard is built on, but what's very important here, of course, is that the implementation details of these requirements are not covered by the standard. So when you design a system, you've got to think about how you execute it and how you implement it. So you can get all the communications and the keys secured, but you have to think about the total system and how you deploy that when you design your system. And finally, the last slide, I just want to share with you, NXP received the Cybersecurity Award at the Smart Metering Europe Summit in 2014. And the judging panel there consisted of the European Network for Cybersecurity and a number of large European energy supply companies, and of course the Smart Metering Industry Group as well. And the commendation was the winning company is supporting the delivery of next generation security architectures by exploiting recent innovations and developing adaptive platforms which evolve to meet the challenge of more sophisticated cybersecurity threats. So we ship billions of bank cards every year. We're using this technology to secure the Internet of Things. It's proven technology, and it's from NXP. Thank you for listening to me. Appreciate that. Thank you.